Brilliant. Hello and good morning, everyone. Welcome to the latest installment of the TAC Young Member Tunneling 101 series. My name's Graham Swarbrick. I'm your host. And today we have Johnny Polson, CEO of Dolenco Tunnel Systems, here to present to you. Johnny has over 25 years of experience with building markets for waterproofing and concrete repair solutions. He has founded and managed businesses in distribution and subcontracting of a wide range of specialized solutions. Mr. Poulsen has, during his time, accumulated know-how and expertise on tunnel and underground structures on the international market. With his experience, he has been leading the development of new, innovative business solutions to accommodate the changing needs in underground construction and continues to develop and adapt in the increasingly changing and difficult conditions for construction. Mr. Poulsen today will be talking about the topic of water management and retaining walls in underground structures. I'll hand it over to Mr. Poulsen in a moment, but just a little bit of housekeeping. If you have questions during the presentation, please put them in the Q&A chat box, and we will address them at the end of the presentation. We'll leave about 15 to 20 minutes at the end of the presentation for questions. And with that, Mr. Poulsen, I'd like to hand you over the mic. Please give us your presentation.
Thank you, Graham. Thank you for the introduction. And also thank you for the invitation today. So what I'm going to do, everybody, is I'm going to share the screen and go through a slideshow, which is there, and it will be a couple of components there. First, the introduction, and a little bit about the business we're working in, then how to address the problems we have with drainage. And then we have some technical information, and we have some projects, some actual projects that have been done in different ways to give you an idea of this as well. So without further delay, I'm going to just give me a minute to share the screen here. Let's see if we have success. It should be there by now.
Excellent. Yes, we can see your presentation.
So what is our background before I start the presentation? I see that the slide is not in here, the first slide, which is about our company. And we are a company that has more than 25 years of background in waterproofing of underground structures. And this is, of course, the basis for what we're talking about today, the drainage angle to this problem. So we will start by looking at the tunnel structure by itself. So it's really a very dramatic thing we're doing. If you have a mountain and you remove an entire section of this mountain, and there's two things that we are looking at as the basics. And the first one is the soil dynamics. Of course, you have a creation over millions of years, and then you have a kind of a natural balance of the water seeping inside the structure, how the load is being dispersed inside the structure, and the same time what we're doing, and we're removing a large part of that. And then in this situation, you have to have a new balance. We talk about the soil dynamics, what is happening. So we have the different phases. We have the excavation, where of course that's the most dramatic thing, and this is why we are also having the initial lining, shotcrete lining, typically on the surfaces to be able to even work there. When we excavate, the soil starts shifting and the pressure goes, so it finds a new dynamic there. So during construction, we have even more problems in this aspect, and this is of course why we have the first initial lining, so we can actually go in and do things. And with the water, we have also a situation where the water is going to change its dynamics inside this new excavation. So in the beginning, you might have a lot of water coming out, and then it takes off a little bit as you're constructing, and then over time, it will kind of accumulate again. So there's the changing dynamics in this. And of course, this also goes for after the whole lining that we have made and chosen for this specific tunnel that we're making, that when we've done that over the lifetime of that structure, we also have to be sure that it's built up of components that makes sure that we have a viable and safe structure for a long time. So one is the dynamics of the soil, and one is you could call it the dynamics of the water. Of course, here you see the very good example of what can happen when we start digging. We have lots of water coming in sections, and of course we have to, short term, we have to address this, but also the long-term effects we have to address. So we are again looking at the three different phases. The excavation itself, where it's very uncertain what is going to happen, and even though we do a lot of bore testing and drilling to see what the soils are like, we still have unexpected experiences during construction. So this makes it a very uncertain and risky business of making tunnels. So when we're constructing, then we have to also take this into account, because besides the design we have, not always have we been able to foresee what really is going to come when we excavate. So for that reason, you have to have a little bit dynamic thinking as well when you start building. And these uncertainties is also often what makes the projects go way over budget. You have to stop this structure being built. You have to do new things that you didn't calculate into the budget. And so this is one of the things. When you build the entire structure, the pressure from the water, which is on the entire structure in the lifetime of the structure, that also creates some remedial work, refurbishments, and so on in the lifetime of the structure. So you have a structure that is maybe supposed to be 120 years old and more, and you have to be very, very careful about what you're doing for this these risks that you have for repair works over the lifetime of the structure. So we have these different phases where we have to really look at the risks. The picture to the right is actually from a tunnel in Colombia, a road tunnel that we made with it's called Toyo. It's the longest. I think it's the longest road tunnel in America. This is 9 kilometers. So we have all this water coming in, and what is the actual problem with that? Why is that a problem? Well, first of all, of course, the safety during construction is jeopardized, so it can make it can have fatal consequences. And during construction, even there, you have to sometimes make a lot of repair work, like injection work or other remedial work that you have to do to be able to go forward with the lining design. The water pressure also compromises and can compromise the structural integrity, not just in the beginning, but over time. So if we have a lot more water pressure than we thought, then we have a higher risk because of the membrane situation and the thickness of the concretes and the fibers or whatever design we chose, that it will fail at some point because we have this also referring to the dynamics I mentioned in the beginning, that you have a changing of the dynamics in the surroundings. And we're talking about many years and different types of risks there. And then, of course, the actual water coming in does different types of damage. That could be on the installations, and it can be on the road where it can be formed as ice. It could be slippery on the rail tracks, electricity. So there's a lot of factors there which is dangerous. Again, with the ice, you can have cracking and spalling. Concrete, you can ice falling onto the surface of the floor in a road or rail tunnel. You could be in a mine where you have also problems with the water. If you have cavities where you store your machines, you don't want water or dampness there. So all these factors makes it a very unsafe way of making a structure if you don't take this into account and look at the water pressure. And of course, then the last and very high cost is the maintenance over the lifetime of the structure. Just one close down of a tunnel is quite expensive, and if you can just optimize the linings so you can reduce this, then you have huge savings to do that. So what do we do? What do we do to handle this water? We have basically three principles that we can use. Either we're trying to block the water from coming through and creating the pressure behind, and this is done with different components. You have the grouting, you have the waterproofing, you have the making a waterproof concrete with wire mesh, with fibers, or crystalline waterproofing, different types of designs of blocking the water. Then we have the second one is where we have it diverted. This with line drains and pipes and different types of, maybe even pipes through. Like if you have a slope, you will just let the water come out through pipes. So try to divert the water so the pressure is no longer there. You can have the initial draining on the rock, or you can have later in the lining, in the outer layers, you can have another drain. You can also drill holes to lead the water in certain places. So different types of diverting the water. And then the last part is where you have a situation where you can just let it drip and basically accept the not so watertight and dry structures. And this can be done in different ways. Also, you can have, for example, you can have plates that are mounted onto the wall, so you don't see it. For example, in a railway station, you may mount plates in front of the wall, so you don't see the dripping, but just let it run and then pump the water out. So what are we doing then in these cases here? Long term, we are injecting, we are making concrete repairs, and we are replacing installations. And these are all the long-term costs that we see, besides the actual cost of closing the tunnel. So some of the components that we use in the design. Now we're trying to adapt the design so it's suitable for the individual structure. And the first part is the concrete or the shotcrete. We can do one or more things to the design of the concrete, the shotcrete. You can make it fast setting. If you have a little bit, do you have a little bit of water seeping? Do you have a lot of water? How to do? You can design for less cracking. You can also choose the very heavy lining. This is typically also done when you have a sheet membrane where you have two cast concrete and a sheet membrane between them, the double shell lining. And you can have the thicker shotcrete layers. You can combine with different additives into the concretes. This could be the crystalline waterproofing, for example, is one of the things you can do. And then, of course, if you have soil which is not so sturdy, if it's goes towards soft soils, you have the steel girders you could put in, the anchors, the anchoring of the wire mesh. You can have the umbrella system put in, so there's different structural stabilizers you can use there. And then you have the drainage situation where you can put different types of drainage in, the line drains, the dimple sheets, geotextiles, to try to take some of the pressure off the structure or lead water away from the lining. And then finally, we see the different types of waterproofing, starting with the grouting. You can use either spray membranes or sheet membranes. They have different advantages and disadvantages. We'll come back to that later. You could mix different types of fibers into the concrete, the crystalline waterproofing, and then finally help it with some injection work as well. So with our experience, we found that the best way to improve these lining structures were to somehow find a way to prevent that pressure on the structure. And we saw in the market that there were different types of products that does this, but we found out how to design a systematic approach to this. And of course, it will, if this is possible, then we can permanently prevent water pressure on the structure and alleviate a lot of these problems and costs. that brings us to the Dolenco drain, which is what you see here schematically shown here. And I'm going to show you a video in a minute. I'm just going to tell you what it's about. It basically shows the principle of Dolenco drain mesh drainage. And it will show what you see here. You have the bedrock, you have the initial shotcrete layer, then you have the Dolenco drain mounted in as the first product on the initial shotcrete. And then you cover that with 1 or 2 layers of shotcrete, different combinations with the build-ups of these linings. Well, let's start the video. As you can see, it's fully embedded into the concrete. So the half pipes modules are mounted from the top down, creating a horizontal and vertical network of channels that will receive the water. And then at the base, there's some kind of detail to alleviate the water away from there. Okay. So as you saw, it's module based, and it is a very slim part. So it's only 14 millimeters or half an inch. I think you are in metrics in Canada, so I can say millimeters, I guess. It's 14 millimeters thick, and for this reason, it's very good for also for repairing, for example, rail tunnels where there's very little space to do with. Normally, there's a very narrow margin for using the lining space. And as you can see to the bottom left, you see the embedded strings inside. You get a good impression on the size of these. And then one module there is 1 square meter. So it's very lightweight, like 660 grams. So it's very easy to work with to mount. You basically have a nail gun with 30 millimeter nails, and you nail that to the surface. When you've done that, you have these half pipes inside the structure everywhere to receive water from wherever it will come out. And that's the whole basis of making it in a systematic way like this. So in a few years, if you have water shifting, which it often does, to a new place, putting pressure on, coming in, trying to come in, it will be received by the strings and led to the base. So in this way, it's a very safe solution for the future. Here's a more schematic picture of how the modules are mounted. Top left, you see the vertical connections overlapping and very flexible. And below that, you see the horizontal connection between the modules, so the water can also disperse sideways to the next module. This is important to make sure that you manage the water and there's no pressure buildup in there. So it can take 8 cubic meter water per linear meter wall per hour. So this is quite significant amount of water. So if you have that much water, you really can't get the shotcrete to stick to the surface. So this is more than adequate to manage the seeping that will come in. And since it's embedded into the concrete, it's a permanent solution. As I mentioned before, it requires very little space since it's only 14 millimeters thick. So you can overlay with like a 50, 100 millimeter shotcrete, and then you're good. The material itself from the product has been chosen to be a product which can be recycled. So you can take it out and actually granulate it and make new products from it 100%. So this is our first step. We also have a second step, which we're just implementing now, and that's a biodegradable version, which is compostable. So if you throw it in nature, it will just be eaten by the plants. Yes, besides the tunneling, it can also be used on second piles, which is another segment for the underground structures, like cut and cover and stations and shafts and other parts of the projects. Now, the main advantage, as I mentioned from the beginning, is the permanent preventing of water pressure. That is the primary function. And this also gives you some advantages if you, for example, are combining with a spray membrane. It makes it possible to stop the water from going to the membranes when you apply the membrane. So it will have time to harden during construction. Often we see that moisture accumulates behind the spray membrane. And if you have the Dolenco drain behind it, it will take the water first, so you don't have to do a repair works on the membrane after that. So you can eliminate or minimize the injection work. Of course, when you look at the picture here, you'll see that that there is a lot of space between the strings, and because of that, you have adhesion between the primary and secondary shotcrete layer. And for that reason, primary and secondary concrete layer will be permanent, both permanent concrete. So the permanent lining you have can be actually calculated to be reduced. So you can save concrete by using Dolenco drain inside the concrete. And this because, of course, because it's a monolithic structure. And let me show you just a little bit on how to mount, how it's mounted, just to show you the easiness of here. This is from a road tunnel in Canada, in Colombia. And in this case, it's from a scaffold. It can also be from a scissor lift. Okay. So we looked a little bit at the to quantify the savings, and we see consistently we have three factors we looked at. We looked at the direct cost, the time saving, and the CO2 reduction as a consequence of this. And we looked at both the hard rock and soft rock structures, and we could see that there's quite a good savings in all three parameters. The one that surprised us the most was actually the time, where we saw recently in the project I mentioned just before, there was a time saving of about 60%. So, and cost savings was like 40%. So there's a huge saving in these structures. And of course, time is one very essential point. The picture to the right here is from a Spanish project where the rail is still running over this scaffold. I believe you can just see the scaffold is just there down to the left corner there. And the train is actually running under this scaffold while mounting the Dolenco drain. And this also illustrates how little space you actually need to do the work. So where to use? We have talked about the rock surfaces, and then I mentioned the second piles, and I'd like to show you a video of the second pile application here. As you see here, first we level out between the piles so it's fairly even. It doesn't have to be entirely smooth, but just fairly even. Two persons can mount between 12 and 20 square meters per hour. And at the base you cover the ends with geotextile so you don't block them with the second layer of shotcrete. And in this case, it's also combined with the horizontal version, which can be used in inverts or basements. Then the water is just let into that and then over to a pump sump, or maybe a pipe on the side. That depends on the project. So besides these two, it can also be mounted on slopes, and in some cases directly onto rock, on brick surfaces, and on very uneven surfaces. A little bit on that now. Here you see the schematics of the video we just saw, where you see the very thin overlay over the second piles, and then Dolenco drain directly onto that, and then cover with shotcrete. In this project, you just saw that it was actually mixed with the crystalline waterproofing into the second shotcrete layer. And at the base, we have a gutter which catches the water. This is 65 millimeters wide. It's used for slim structures where this is needed. There will be a little bit later, I'll show you some other detailed options here for that. Here you see the rock wall, which is the same type of principle. You have the initial shotcrete layer on the rock, then you have the Dolenco drain, and then the gutter at the bottom. And if you have a lot of water coming in a point, you can use the vertical line drain to capture that water if it's a very high volume of water. In the arch of the tunnel, you have the connection between the surface of, let's say, a station or shaft, and then the tunnel arch itself, and then you have to have some kind of catching the water there. That's point number. Okay, two. They both have number two. Point number two to the left. The picture to the left. You see it's caught by there and then led to the base on each side of the arch. And then the photo in the middle shows where water is led into the Dolenco gutter drain at the base. And then, of course, it's let out in strategic places depending on the design, certain points and whatever detail there may be there. Here we see the connection between the wall and the floor for when you use a Dolenco drain in horizontal surface. And as I mentioned, it's typically a pump sump at the in the floor, one or more strategically placed there, depending on the size of the area. Yeah, you have the slopes where you typically, in this case, you have the initial shotcrete layer on the slope, and then a reinforced first layer of shotcrete with anchoring, then Dolenco drain, and then another anchored wire mesh shotcrete over that. That is, of course, the thickness of that is very variable and often quite high, like it could be a meter or more thickness depending on the structural needs in the project. Dolenco drain can actually be used directly onto rock. This is an example from Canada where they had a problem with water coming in and they could not get the shotcrete to stick to the wall. So they basically said, we're going to try and use Dolenco drain on this very uneven surface, and it actually worked. So they just basically took a wire mesh and pushed over the Dolenco drain and anchored that to the wall and shotcrete the whole thing. And it made it possible to get the shotcrete to stick to the water. It didn't stop all the water from coming out, but 80%. And then after that, they cast concrete onto that, which stopped the remaining water seeping. And it makes sense because when you have a situation like that, you cast that concrete afterwards, the water will not try to get through all that concrete. It will find a way back into the incomplete network of strings, which is left there behind, because it's not going to be complete network strings because of the, in this case, many of the strings are at a distance from the rock. And so when you shotcrete, you'll close a lot of the strings, but it still had the effect that you needed to have. So it could lead the water to the base. Using Dolenco drain on brick is also a fairly simple procedure. You basically nail the modules to the surface of the bricks. If it's soft, if it's a harder stone, you put a thin layer of shotcrete on first, and it's a good idea also to combine that with a thin wire mesh like you see here on the picture, and then you can just have a very thin layer of shotcrete, or maybe trowel on a render. That's also an option. Different situations, different methods there. And this picture here is for showing you the variability of the mesh. It can actually be put on very, very uneven surfaces. And let me show you just an illustration of this application here. So you can see the contours of the tunnel wall there. The seeping, the anchors. And here is from a scissor lift. You can see the tools you need. You don't need big equipment, just a nail gun with a battery. That's it. So it's easy to get in and start the work and get out. So if you have a tunnel repair where you only have a little time during the night, then this is an ideal method. The modules are very lightweight. You can see it's very easy to manage there. So sometimes we have this more water coming in. We have 3 options on how to address them. The first one, number 1 here, is just a crack. And if you have a crack seeping, then usually we don't do anything to that. We just let the shotcrete over it and let the water find the nearest string and alleviate the water pressure into that string. The second point is if you have enough seeping for a 10 millimeter rubber hose, you basically drill that into the structure and lead the rubber hose into one of the Dolenco drain strings. And in this way, the water will be running inside the strings, and you can shotcrete over this without problems. And the third one is the ones I mentioned in the beginning also, that you have a point where there's a significant volume of water coming in, and you use the line drain to contain the water inside there and just put the Dolenco drain around that. When you have this in the package as well, when you're designing, then you're very, very sure that you'll have all bases covered there to get a good result. And then we have a list of visual inspection for the installation and to test if it's functional. I'm not going to go through this list here. This is just typically that you, after you have covered it, you look at the base and you see if water's coming out of the strings at the base. If you have a pump sump, sometimes you make a shaft depend also on what is needed in the project. You can have shaft where you can do the flushing of the drain at the base, and so that there's different ways of doing that. So basically it's visual testing, measuring how much water is seen in the pump sump is another way of doing it. So that there's yeah. So here's one of the other ways of doing the detail at the base. You see in the circle there in the middle. This is basically done by putting the Dolenco drain onto the wall and mount a perforated pipe at the base, and then put a strip of geotextile only over the end of the module, not the whole surface, but just the end of the modules and around the pipe. So you make sure that there's no shotcrete being shotcreted and blocking the end of the modules, so the water can run from the modules and into the perforated pipe. And here in this case, it's just shown with one layer of shotcrete, and that's it, sufficient. Here you can see an example with a similar situation, but it is combined with a sheet or spray membrane. Here's an example where you simply just let the water run out on top of the slab and into a drain on this could be in a shaft, for example. You just basically make sure you don't shotcrete the end close of the modules, and the water can run out to the floor. Here, actually, I only want to talk about detail E here. which is an example where you see the Dolenco drain is just mounted past the slab and into a stone drain layer beneath the slab. This is also an option. So that's detail E. And then finally here, the final sketch is of the Dolenco gutter drain, where you see the narrow 65 millimeter wide drainage and strategically mounted horizontal drain pipes on the side of that. And in this case, there's no need for the geotextile, just mounting it over the strings. So finally, some examples of application, different types of projects. The first one here is a road tunnel from Switzerland, where the tunnel actually collapsed and they rebuilt it. And because of the very small space to rebuild, they basically took a Dolenco drain, mounted on the surface and covered with shotcrete. And that made sure that no water came in. The second one here, this is from Canada, Montreal, the REM, and this part here is, we did different parts of the project, but I'm just gonna, here it's just one part is the tunnel where it was actually two rail tunnels, and the wall between them were taken down, and then they expanded the tunnel, put steel girders in, umbrella, and shotcrete layers combined with the spray membrane and shotcrete layers. And before the shotcrete, also a smoothing layer. And during construction, they found that the water came to the membrane, and so it was not possible for that to harden and get full function. And so during the construction, they changed the design to include the Dolenco drain behind the spray membrane. And that made the work easy and go forward without having to do the repair work. Here's another project also from Canada, Montreal, and this is a shaft. And what is interesting here is that the illustration in the middle is the upper part is soft rock and the lower part is hard rock. So the lower part is with anchors and shotcrete, and the upper part is with second piles. And both these parts, the whole surface, were made with Dolenco drain also on the surfaces all the way down, and covered with shotcrete and a spray membrane and shotcrete. And the detail to the left bottom, that is not easy to see. So let me just try and expand it a little bit. What I would like to illustrate here is that in this case, it was Dolenco drain was mounted like in one of the examples I showed you before, where the Dolenco drain is passed through past the slab and into the stone layer beneath the slab. You can see that the 100 millimeter, that's the Dolenco drain end that goes 100 millimeter in beneath there. And of course, you would have to put a strip of geotextile over the modules, Dolenco drain modules, when you before you cast the concrete, so the cement paste will not seep into the strings and close them. Okay. Here's a refurbishment, a road tunnel, and this road tunnel was actually closed for a few years because there was so much water coming in through the roof. And you can see that on the photo there that it's a very, very bad concrete. So basically, when the water was running through, they removed the bad concrete, cleaned the reinforcement, put corrosion inhibitor on, built up with new shotcrete, Dolenco drain, and it was finally a successful tunnel work. The reason there's so much water coming through is because there's a river just on top of this. It's just actually under a river, yeah. So there's a lot of water coming in because of that. Here we have an example of the brick tunnel, where you see the seeping on the picture there to the left, and there was a lot of work done on the joints first, and then basically mounting Dolenco drain and the wire mesh same time onto the surface, and troweling on, in this case, troweling on the mortar, and also combining this case also with spray membrane, and then another layer of shotcrete render. Sorry, that was a mortar render put on here. Here's a little bit closer to home for you. This is in Philadelphia, where there was retaining walls that were leaking, and the only possibility they could see was to remove 10 centimeters of concrete and then mount the Dolenco drain and then cover again with 10 centimeters concrete. And that solved the problem, and it's a very, very sturdy and good solid solution to do like this. And then I think finally, this is from Mumbai, a project where they had a double shell lining in the design, and they changed to a shotcrete because of time problems, and because they didn't have any structural strength and not enough concrete with the shotcrete to take the pressure. They put some parts they use Dolenco drain, and some parts they use other. You can see here on the picture, there's also line drains besides Dolenco drain behind the shotcrete to be able to put on the spray membrane. And I believe this was the first project where they did that combination in India. And the final project is from the REM. Again, that's a station where you have the second piles leveled out between the second piles, put a Dolenco drain on, and then the shotcrete, and combined with a spray membrane as well. So sometimes we use together with spray membranes, sometimes with fibers, sometimes both, sometimes stand alone. It very much depends on the project, what we're doing. And here also you had ramps, the wall for the ramps, the cut and cover. Okay, let me get back.
That was a fantastic presentation, Johnny. Thank you very much.
I hope you have a little bit information, and I'm ready for any questions you may have.
Absolutely. Yeah, that was
So shoot.
fantastic. I had no idea that this technology existed, and that it was, when you started your presentation, I thought maybe it's like a newer item on the market, but it's clear that it's, quite worldwide in use. So I'm gonna go to our chat box now. The first question is from Amir Ali. As many clients require using waterproofing membrane systems around the box tunnel or inside the board tunnel, how do you use this application of both Dolenco drain systems with waterproofing membranes for such structures?
Well, it has to be, Dolenco drain is used in a variety of combinations. That would be my first answer to that. And then if you want to be more specific, you can, I'm not sure if your question is more specific than what I hear here, because when you say membranes, we separate typically between the spray membranes and the sheet membranes. And Dolenco drain can be used in combination with both of them. And which combination you use, we actually very often have meetings, Teams meetings with the engineering offices, and just go through the details and try to help optimize the design. And we discuss, what to do in different situations. Sometimes we have the whole tunnel where we are basically getting the information about the whole tunnel, and then we discuss, okay, in these sections there are different solutions. So it's actually it's a variable. So I would say, if you talk about the sheet membranes, but you can also follow up if you have a more specific question, if you want, the person who asked that. But if you talk about the sheet membranes, we also have that question sometimes, and what we recommend do there is to, after mounting Dolenco drain, you just cover with 2 centimeters of shotcrete and then cast onto that, because then you don't have the cement paste fill up the string, right? So that works if you just have a sheet membrane concrete. So you have Dolenco drain behind the sheet membrane there. That's how we would do it. So, but there's a number of ways how to combine this.
Interesting. Yeah, I think that's a great answer. Um, Next question is, I mean, a lot of people who have been in mining applications, hard rock applications, you see quite frequently the formation of, calcium deposits and such things where water is ingressing. Do you have issues with this system with like clogging of this, or is there a mitigation strategy for when the groundwater is not clean water, it's maybe bringing in sediments and things like that?
Yes, we do have an approach to this, and the first approach is that when you have this sintering, you when you have the string from this reach, I don't know if you can see this, but when you have
Yeah,
the
we
string from this,
can. We can
you
see
can
it.
actually see the connections. You know, they have connection between and you have the connection between horizontally here, right?
Hmm.
So what happens? First of all, when you mount this, it goes into the string here, and this is a very smooth material. It doesn't stick to that. So that's the first point.
Okay. Yeah.
That's the first point, right? So it will actually be flushed out, but you can talk about having a clean out of the horizontal drainage, right? But the
Hmm.
story is not finished there, because you could also say that sometimes you'll have so much material coming out, or you can have a piece coming off and blocking one of the strings, or
Hmm.
maybe even two or three or four of the strings. And this is okay that this happens, because this is in the design of the having so many strings, that the
So many
water, if
networks.
water
Yeah.
accumulates there, it will just go a little bit up and then rise, and then go to the next one and the next on the next string. So we actually prevent this pressure buildup, the permanently prevent pressure. That's the main focus here again.
Hmm.
Um, but we do have actually in our patent, we also have a last resort, we call it. We don't really see it being used, but it's possible, and we often talk to the clients about this. And this is that we have a system where we can, with the GPI, you can scan up to 15 centimeters into the structure, and you can actually identify a string if it's full of water or
Hmm.
if it is empty. So that when you make a horizontal scanning, you can just see that, and then you identify, so you can very quickly identify where the blockage is. And then you can drill in at an angle above that and route it
Hmm.
out mechanically or with water pressure. And
Right.
then just close it with a fast setting waterproof mortar after that.
Hmm. Perfect. That's a fantastic answer. Our next question comes from Mei Chung. What is the design life and warranty for these drains?
Well, it's a permanent solution. The material doesn't go bad. It stays like it is. And after 120 years, it's designed for 120 years. And what we can say is that the material is made of, it doesn't go bad. So after 120 years, you could break down the structure, take out the material and
Hmm.
recycle it, make new products. That's
Hmm.
part of our DNA to do this. So we have a CO2 footprint of 1.2 per square meter.
Hmm.
And I was just very slightly, I was touching upon the subject, but we are developing further, and we are actually now, we have made a new version which is 100% biodegradable. That means it's compostable, so
Hmm.
it disappears over the years. It will disappear from the structure, right, as it
Hmm.
disintegrates. It will flow out and will be eaten by the plants, so the CO2 footprint is zero on that.
Right.
So that's the next. And of course, if you think about it, if you can just it's kind of a formwork that just disappears after that. So you just have the canals left in the concrete. So now you just
Hmm.
created a network inside the concrete.
Where it's already draining anyway. Oh, it's brilliant.
Yes.
Perfect. Thank you very much. I think that's well, we're just about out of time. If there's no further questions, I think Miss Johnny, you seem very eager to answer questions, so I'm sure I can advise our listeners that if there's any further questions they have, that they're more than welcome to direct them to you. And we'd like to thank everyone for joining us on their lunch breaks slash mornings for our Pacific time zone guests. With that, I'd like to say thank you, everyone, and we look forward to seeing you at the next TAC Young members. Thank you very much, Shawnee.
Thank you too. Thank you,
Cheers.
everybody.
Bye, everyone.